Okay, great. Uh, Thank you, everyone, for coming out today. My name is Julian Thibault. I'm the president of the American Research Center in Egypt, Detroit. And joining me is Marisa Speitman, also our vice president of American Research Center in Egypt, Detroit. Thank you so much for joining us this afternoon for our Zoom lecture, Conservation of Ancient Egyptian Metals, Latest Perspectives, given by Dr. Almoatzbellah Elshahawi. Dr. Elshahawi has been a conservator at the Egyptian Museum in Cairo since 2021, specializing in ancient Egyptian works in metals and coins. He was a graduate intern at the J. Paul Getty Museum for 1 year and received a master's degree in conservation from Cairo University in 2017. Dr. Elshahawi was a 2009 through 2013 Cairo University Fellow. He's been a conservator at the Grand Egyptian Museum Conservation Center for 6 years and most recently received a PhD in metal conservation from Cairo University. Thank you for taking the time to speak with us today, Dr. Elshahawi, and please join me in welcoming him to American Research Center in Detroit. Just to let you know, there will be time for questions at the end. You can put your questions into the Q&A box as they come up to you, or wait until the end. After Dr. Elshahawi speaks, we will have time for Q&A, and we'll read out your questions in as much time as allowed. So thank you again, and I'll hand it over to Dr. Elshahawi to give us his great lecture.
Thank you so much, Julian, for this introduction. And first of all, I would like to thank the ARCE Detroit chapter for giving me the opportunity to be with all of you today. And our lecture, it's about conservation of ancient Egyptian metals, latest perspectives. And I'm going to talk about two main topics. First, about the authenticity of a bronze cat from the Getty collection, and the second topic about the conservation of ancient coinage. As for the cat, an authenticity study of an Egyptian bronze cat, modern to ancient. Here's the cat information. So over 6 months, Jeff Maish, who is a conservator at the J. Paul Getty Museum, and I have conducted a research on metal object in the J. Paul Getty collection. It is known as a bronze cat. J. Paul Getty saw the cat at Spink and Son Gallery in London while out with friends, and it became one of the first ancient objects acquired by his newly formed museum. And he wrote in his diary on June 7th, 1955, "We all admired the bronze Egyptian cat, and I bought it for £600. Here we can see the cat from all the sides. So what led the cat's relegation as an imitation? Perhaps one of the main reasons was its style, as we can see here from the pictures. Ancient Egyptian depictions of the cats ranged from sophisticated to primitive. This cat might be primitive, but a similar style, it is not necessarily an indication of forgery. The cat also exhibits unusually deep-set depressions for the eyes. These may have held now missing inlays. We have also found handwriting, as we can see here in this area. Sorry. We have also found handwriting on the underside of the wooden page that reads, "Mounted by W.T. Reddy, November 1892, 55 Rathbone Place, London, W. And we did a research on this name, and we found him a 19th century business directory listed ready as a dealer in antiquities, coins, metals, and gems. And he was working as a conservator at the British Museum for part-time. So a fake or not a fake? For many years, a bronze cat statue at the Getty Villa was believed to be one of these imitations and was left alone in storage. Decades later, it was classified as an imitation of an Egyptian statue, not as an antiquity. And many questions have been raised about the authenticity of the cat for many reasons. Several odd repairs on the cat's tail, as we are going to see this. The surface appeared to have been stripped and was very glossy, giving it an artificial look and contributing to its suspicious appearance. Comparisons of the interior to the exterior bronze surface indicate that the cat had been aggressively cleaned, leaving a smooth and typical corrosion pattern on the exterior surface. Are these what led people to believe it was an imitation or forgery? But recent discoveries and scientific tests suggest that it is in fact ancient, and let's see how. And to confirm that, a technical study has been done on the cat using digital microscopy, as we can see here through the investigation using digital microscope. The corrosion products on the exterior surface underside the cat on the tail, and here also we can see the odd repairs on the bottom of the cat. Also, as for the tang, as we can see here, the tang, it was actually like a mark when people in ancient trying to produce metal objects. We can see here four tanks from the cat bottom with drill holes, as we can see here, which were used to secure the cat onto the wooden base. Likely indicate the holes are part of modern mounting. Also, the sculpture interior, as we can see here in this area, reveals green and white corrosion. Also, we can see here the wooden base and the iron rust and the phenomena it's called the iron weeping, and this happened due to the high amount of humidity. Peter Myers, who is a conservation scientist at Lahma Museum, and I did a microstructure study on the cat. Optical micrograph of microstructure showing dendritic shape cast areas of metal core, grains of copper-rich phase, lighter areas, as we can see here, and surrounded by lead-rich phase, lead segregation with the gray and black areas, and intergranular corrosion of red color cuprite. This gives us a high probability that the cat is authentic. Also, as for the radiography, the cat was x-rayed and found to be an accomplished casting with few defects, radiographically opaque light areas, as we can see on the outer side of the cat, hinted at something nestled in the head. we decided it was time to remove the wooden base added by Reddy in 1892 and to take a closer look inside. What we saw on the interior was a completely different surface of varied topography with corrosion formed over a very long time. In the head, a dark mass, as we can see here, was tugged into the cavity, which also pointed to ancient modeling and casting. As for the handheld XRF analysis, the cat also has been analyzed using handheld XRF to learn more about the elemental composition of the cat alloy. And the results gave us information about the alloy of the cat that it made from leaded bronze alloy. Copper is the main element with a high amount of lead and variable traces of tin and iron. As we can see here, the XRF spots. So comparison with other examples of bronze cats from different museums, a literature review was conducted to find published analysis of similar cats from different museums. The aim was to compare alloys to the Getty cat and determine if the composition was consistent with ancient castings. As we can see here in these tables, the study revealed that with a few exceptions, the primary elements of the cat objects in several foreign museums are somewhat compatible with the elemental composition of the cat in the Getty Museum. Here, here also another examples from Harvard art museums. And actually, one good thing that I have to say about Harvard Art Museum, they have an amazing database that you can go enter and you can make a research and you will have at the end the elemental composition of the objects with the parameters that they were using uh, during the analysis. So materials that was suspected to contain wax and corrosion products was supplied for characterization. It was analyzed by Fourier transform, infrared spectroscopy, FTIR, and gas chromatography mass spectrometry, GCMS. FTIR results showing that corrosion product is best matched copper chloride hydroxide, and the 19th century coating was analyzed and found to be a mixture of beeswax, paraffin wax, and an oil, as we can see here from the FTIR chart. Inspection of the interior revealed a dark gray material, as we can see here in this area inside the head of the cat. We suspected that this dark material might be a clay-containing core material. The material appeared to be fired and possibly presented remains of a casting core. If so, could it dated by a process called thermoluminescence? To find out, we have sent a sample to a dating laboratory in Oxford. The material indeed contained clay and could be dated to between 1700 and 2700 years ago. Taking together The alloy and clay core date point to the cat being an ancient Egyptian work after all. The study of characteristics lead isotopes helped to locate a production site more precisely and the source of the lead. And as for the source of the lead, Patrick from the Oxford lab was able to run the lead copper samples, and Monica Genio from conservation from the GCI did some interpretation based on the database in Oxford. Patrick found it didn't match data he had from Egypt from earlier periods, and Monica found that closest parallels to be from the Cyclades, potentially Kythnos. This is pretty much north across the Mediterranean and a little west of Egypt. The surface is dark, fairly even and shiny, not what we could expect from an ancient bronze. Closer examination, however, revealed some restriction suggestion that the 19th century restorer may have employed a rather aggressive oppressive treatment to produce an even surface. We can notice this from the surface here and the surface here after removing the coating layer. Here the surface is very glossy, and here we can see the surface that actually match with the other ancient metal artifacts. The surface appearance was further evened by the application of a coating. Today, this evidence seems inconsistent with a corroded ancient bronze surface and thus somewhat deceiving. We removed a small window, as we can see here from this picture, of the coating with organic solvents and discovered a more characteristics corroded silver beneath, as we can see here. Also, coating layer was removed, and this revealed the underlying aged surface. So, as for the results and conclusions, through the investigation of the interior surface using digital microscopy, it became clear that the corrosion layers formed naturally over an extended period. The chemical composition of cat's alloy corresponds well with other ancient Egyptian bronze cat according to portable XRF results. The TL results indicate the core was heated between 1,700 and 2,700 years ago. This would date the cat as early as circa between 500 to 600 BC, a time consistent with other known ancient Egyptian bronze cats. A technical study of the cat using visible and microscope examination, X-radiography, metallography, X-ray, fluorescence, and most significantly, thermoluminescence dating of the core material within the head confirmed that the cat authenticity. What is the next for the cat? Additional provenance research may also clarify whether this cat came from Bastet's site and how it traveled to London and what collections it was in from 1892 to the time of purchase by J. Paul Getty in 1955. So away from the cat and go to conservation and the treatment of ancient coinage. So this part actually might be very important to historians and of course for conservators. The study and conservation of ancient coins can provide us with lots of significant information, including but not limited to acquiring accurate data for the region, economic, social, and political conditions about region and period, industry information and location of mining, information about fashion, hairstyles, as we can see here, and foreigners, ancient religion, and writing development, particularly if we are talking about Islamic coins. And of course, we conserve the coins for long-term preservation. Deterioration factors and corrosion products. The most common problem affecting conservation of metals is corrosion. It is an accelerated process. Definition of corrosion: metal back to the raw materials by acting with environment. So this figure, as we can see here, explain how the corrosion process happen. The element in a stable condition in the nature, and while extracting the element from its raw materials using a certain energy, and at this point the metal has transitioned from a stable to active state. The metal then attempts to return to its original state in nature by creating corrosion products that are identical to the raw materials. So we must determine if the corrosion is desirable, undesirable, or dangerous. Here, as we can see here from this figure, a typical corrosion layer products of bronze coins. We can see here the metal cores, two layers of oxides layers, and the carbonate layer, and sand and soil deposits in the top of this corrosion layer. And in high relative humidity, active corrosion, as we can see here, will be formed, and we'll discuss active corrosion in more detail later. Corrosion types, different types of corrosion according to the composition of alloy, the manufacturing technique, for example, the striking process during making the ancient coins often led to cracks, particularly on the edges, the nature of surrounding environment. Also depends on the nature of corrosion. The nature of corrosion are im impervious or active or passive corrosion. So active corrosion, this type of corrosion, it is most common of archaeological copper alloys and is known as bronze disease. It takes place when chlorides react with bronze or other alloys containing copper and occurs where the RH is high, above 55%. The corrosion reaction is progressive and may rapidly cause extensive damage, which means that the metal is not protected and is constantly corroding, leading to severe damage. And it depends on the oxygen, water, and pH. The transport of chloride from a contaminated coin to other coin could spread this type of corrosion. Aspects of active corrosion are cracks, deep holes, and powdery, as we can see here from these examples. I will not go in more detail about electrochemical corrosion because this might need to several lectures to go in deep details about how this kind or this type of corrosion happen, but this actually just briefly happen when two different metal, one of them more noble and the other less noble, as we can see here from this table. Let's have an example between silver and copper. The copper element who will have to be corroded due to uh, the electrochemical corrosion that will happen between the silver and copper. And in this table actually it is very important to the people who are working with corrosion products and particularly with copper alloys. You can see here a typical or most of corrosion products of copper and its alloys with compound name, chemical formula, and the color of corrosion layer. So also quickly about the dye deterioration, cutting of ancient dyes used to be done by hand, which was a time-consuming process, and dyes were not unnecessarily discarded while still useful. As a result, they were rarely replaced as a pair. It's common to see coins struck from one fresh and one deteriorated die. Coins dyes deteriorate at different rates and in different ways. Low dye pressure, improper preparation, treatment of dyes, excessive wear, overuse. For example, let's say some of the dyes that has been used in the past made to make 10,000 coins, and that's it. After 10,000 coins made from this die, we have to change to this die to use another one. So if we are keep going to use the same die after 10,000 coins that made from using this die, that's mean that we cause overuse of this die, and that's caused a deteriorate for this die. So as for coinage conservation, so conservation procedures, it is divided into multiple steps. Goals of conservation, as I mentioned in the beginning of my presentation, we do conserve the ancient coins for allowing long term of preservation, reading the writing and finding fine details and patterns for numismatists. Documentation and condition report. We should make a condition report on the coins that we are working on. The condition reports include ID numbers, material provenance, location, picture of the coin, of course, for the reverse and the obverse, and so on. Analysis and investigation. The ideal way to learn about the coins is to conduct a research and analysis to answer questions about the material, manufacturing techniques, and deteriorating aspects in order to devise the best conservation plan for the coin treatment. Cleaning process. This includes mechanical, chemical, electrochemical, ultrasonic, plasma, and laser techniques. Stabilization if necessary, due to if some coins severe from active corrosion. protection isolating by applying coatings or corrosion inhibitors, or you can apply both to make an extra protection. At the end, you have to display your coins or storage or rehousing. As for displaying, to have it and accessible for the researcher as well as for the museum visitors. In this figure, you can see the condition report, including the information about the coins that you are working on. In this table, also a simple database of coins includes ID number, container, title, current location, date, material, weight, dimensions, coin axis, description, and surface condition. So as for digital imaging, coin photography in action, as we can see here, the ideal way to photograph your coins is to use a copy stand, as we can see here in this picture, so that there is no shaking and the camera is vertical on the coins. In terms of lighting, we can use one source of light from a 45-degree angle, but I like to utilize two sources of lights from two angles, 45 degrees. So these images shows documentation, measurement of dimensions, axis and weight of the coins, drawing and documenting the decorations and writings on coins can be done in a variety of ways, including freehand, uh, drawing, using computer software such as Photoshop, AutoCAD, 3D Max, Illustrator. Another method known as RTI, reflectance transformation imaging, can be used to investigate and photograph of coins to reveal surface information that is not disclosed under direction empirical examination of the physical object. As we can see here from these pictures, here's the original coins and here's the results of using RTI, using different filters. As we can see here, if you are comparing all of these shots, this one might be the best. And actually, this technique became by culture heritage imaging. They have an amazing website that explain about how you can use RTI for photography or documenting the ancient artifact, not only coins, but the idea of this technique that you have to use it with any artifacts with flat flat surface. So you can use it with the books, papyrus, any flat surfaces. Scientific investigation and analysis, we can use microscopes, goggles, and USB microscope, and this one portable, so we can take it with us to the site away from the museum. And this we use it to know the nature information about the nature of metal and its alloy. I didn't the elemental composition of alloy, and also support the work of archaeologists, characterizing and identifying the external surface nature of corrosion products, identify the best conservation approach as necessary, help in determine the authenticity. So examination with digital microscope, we can see here this actually some example of coins from the J. Paul Getty Museum. It is Ptolemaic coins, the coins that I like and I love to work on. We can see here the active corrosion spots on the coins, the cavity of the coins filled out with active corrosion, and this coin actually one of the best coins that I have ever worked. As we can see here, the corrosion looks like the tree leaves, and this an amazing shots. So let's move to optical microscope. Also, we can use optical microscope to determine the salts, to identify the salt grains, cracks, the corrosion fibers, and also we can see the and identify the active corrosion on the surface of the coins. X-ray radiography also here we can use it because it is a non-destructive methods. We prefer to use it just once the coins detected. We can learn about the shape of the coins, like the outlines, reveal fine details. We can also determine if there is remnant metal or the coins, it is completely turned to corrosion. Metallography examination, microstructure. Through this analysis, we can learn more about the manufacturing technique. As we can see here, the dendritic shape that mean the coin was casting, or we have the twinning, that's mean twinning shape. As we can see here, that's mean this coin made by hammering process. So using also scanning electron microscope, through using scanning electron microscope, SEM, we can obtain information about the surface topography and composition of the sample. Here it is a good comparison between using different methods of analysis, or either elemental analysis like using XRF, scanning electron microscope with ADX, or compound analysis like using FTIR or XRD. And I have to mention that for the analysis technique that we are using, as well as the conservation methods, all of these should be non-destructive techniques. Here we can see using handheld XRF for a collection of Ptolemaic coins at the Getty Museum. And we can see here the results showing that coins made of copper, lead, tin, and traces of lead. And here is the chart. The tall one is for the main element, the copper. Let's go quickly to the treatment process. So the goal of conservation process are remove corrosion products if they are active or destructive. One should not remove protective or stable corrosion product, identifying fine details and making them legible for numismatists, planning for long-term preservation. The most important thing when we are dealing with the conservation of ancient metals, it is how to make a decision. So through making the right decision, we can have a good results after our treatments of the metals that we are working on, because at some times we don't have to clean them, because at some point improper cleaning that might reduce significantly their value, particularly if the person who are dealing with this not have the required experience. How many corrosion layer are there? What might the corrosion layers be? These actually will differ depending on the coin composition, and this actually the very important thing. In which layer or layers is the original surface detail preserved? In metal core layer, or in cuprite layer, or in malachite, or in another layer of corrosion. Here are some examples of the coins in various, as we can see here, in various preservation conditions that require careful consideration when deciding whether or not to trade them. From actually left to right, the first two, those actually need to be treated, as we can see here, active corrosion, an active corrosion from the name, it is active. If we are not taking the action to try to stop this phenomena from the coins, at some time we will lose the coin. So all the first two conditions need to be cleaned and treated. And also for this, but this actually for different reasons. This might be for numismatists, as we can not see here the inscription or details on the coins. So the idea here of the treatment is to remove the corrosion layer from the surface of the coins to be able to read the inscription and writing to be accessed for numismatists. Here in these examples, the coins are in stable conditions. We can read the details, so we don't have to do any further treatment. The coins are stable. The inscription can be read without doing any conservation treatment. So things should be considered before coins cleaning. So we always should work under microscope. We have to try in a small area, might be on the edge, in a small circular motions, and gently remove the corrosion layer and go slow. And you have, if you are working as conservator, particularly for metal object, you have to be very patient. So cleaning process, cleaning is a basic procedure in conservation, and I will go also quickly a little bit. The best way to conserve metal object is mechanical cleaning. If you have your coins in good conditions, corrosion stables, no cracks, no weak parts, you can go only with mechanical cleaning. This actually, uh, mechanical cleaning might be take lots of time, but this is the best way to clean your coins. But in another way, at some point, we have to use the chemical cleaning. So here's the tools that we can use it with mechanical cleaning, scalpels, fiberglass pen, ultrasonic pen and bath, and other tools like micromotor. And in these pictures, we can see here mechanical cleaning of some coins. Under microscope, we can see with a good vision to remove the corrosion layer from the surface. And as for cleaning and other processes, so cleaning is good to save the coins from loss, but at some point, some people do tooling and painting or coloring. Toning, that's mean some collectors or group of people that have like a private collections with coins that have the inscription on the surface that are not very clear. They are using a tooling like metals tools to make the inscription on the surface uh, with to be more clear and to be easy reading. So tooling, it became like a forgery or counterfeit of coins, even the coins was authentic. And painting, there is also some people trying to do like a patination or applying a patina on the surface of the coins. And for plasma and laser, here is the requirement of using both techniques. You have to be trained. You have to observe the area that you are working on. You have to wear glasses. The advantage of these methods, rapid, no additional waste, environmentally friendly, and disadvantages, particularly for both actually for the plasma and using laser cleaning when you are make an investigation for the area that you were treated with using plasma or laser cleaning. Under microscope, you will see the area has some melting point. So as for consolidation, at some point, when you are working with coins, you have like a weak parts, and so you have to make a consolidation using searing, pipette, brush, and you have to do this under vacuum. One of the famous materials that we are using while make consolidation of the weak parts of the coins using paraloid B44 or B72 5% in acetone to make like a temporary consolidation and then to continue with other cleaning process. Chemical cleaning, let's say chemical cleaning, I don't like it, not just Motas, but all conservator who are dealing with ancient metals. Chemical cleaning, it's like a headache. So the idea of chemical cleaning, let's say at some point or when that I have to use chemical cleaning, here's the questions. At some point, like I joined some foreign expedition who come to work in Egypt at archaeological sites, and they are coming paying a lot of money. They don't have enough time to stay for a whole year. They are coming just for 1 week, and they have target to complete the whole process of treatment of a group of coins. If I'm going to use mechanical cleaning, that will take a lot of time. But at some point that I have to chemical cleaning because it's more quick compared to mechanical cleaning. But if I decided to use it, I have to do some procedures like so start with the low concentration, stop before reaching the original surface and metal core, do a temporary protection for the affected original surface. If you want to continue using chemicals, like I have said, for the temporary protection using paraloid, renew temporary protection if you clean the surface of your coin with ethanol or mechanically. Don't use any of the following materials like ammonia, hydrochloric acid, or commercial polish cream as mirror. And please never leave your coin in chemical bath without supervision or for a night. And you have to check your pH of the last bath on the surface of your coin. At the end, after finishing the chemical cleaning, you have to do two processes. First, you have to make a rinsing of the coins to return again the pH to be nature using distilled water. And also you have to make a drying process to get rid of the water that you used in the washing process. Chemical cleaning methods, you can apply it with poultice, make a gel, or in a bath. Here's the and also important table that you can use these materials when you have these of corrosion layers or soil deposits. For the mass treatment, at some point, you will have to work on a huge group of coins, let's say a horde. So you can't just go one by one. You have to make a cleaning of these coins by a group treatment. So you put all of the coins in the bath and you make a global condition report working with chemicals in large container, plastic containers. Here you can see the name of the materials and the percentage and in which material, in which solvent that you are using, and you have to check your coins one by one and gently brush them. One quick mechanical cleaning at the end through rinsing. And finally, you will probably need to protect your coins by applying a coating or storing it. Here's the rinsing process using distilled water, and minimum we do this 3 times, each time for 1 hour, and then using distilled water, and then you have to check your pH. If you reach your pH again to nature, which is 7, that's mean two things. You are completely get rid of the whole corrosion layers from the coins. Also, there is no any residues of the chemical materials that you used in the chemical process. If your if the pH of the coins that you are working on is still not reach at 7, that's mean that you have to make again a rinsing process, because you are still have either corrosion layer or corrosion products, or you still have a chemical a residues of the chemical materials. So you have to again. At the end, you have to make a drying of your process after rinsing process by using hair dryer, or you can put your coins in the oven between 40 to 50 degrees for 15 minutes, and then your coins will be ready for the coating or applying corrosion inhibitors. So for active corrosion and bronze disease, also you have it is need more times, which are we don't have enough time to go in more details with how to treat active corrosion. But later, please, if you have any question about it, I'm here to answer these questions. And this a good table that it made by myself, which the materials that are good to use with while conservation, or while making a conservation of ancient coinage. And here's also the all types of um, conservation methods, the tools, equipment, and materials that can use with different cleaning techniques for ancient coins is presented here in this table. For joining join if you have like a coin broken to two pieces or three parts. You can join these coins using parallel 44, 50% in acetone. And also if you have like a gaps or a holes in some coins, and this will affect on the structure of the coins that will cause the will cause losing, or it will be make a coins broken. So you have to fill this with paraloid and microballoon B44 40%. At some point we can do a retouch with a different color, but we have to write this on the whole treatment uh, report. And as I said, at the end we can make isolation and protection using coating, using paraloid like 10% in acetone, or you can using corrosion inhibitors as the scientific research goes to using natural extracts from plants. At the end, also, if you have a very good surface and very flat, very smooth, you can use microcrystalline wax. It is good as a protection layer for ancient coins. Here is some coins before and after treatment. And here's the packing of some coins at the Grand Egyptian Museums. At the end, the whole process that you used in the conservation and the treatment process on your coins, you have to write it here in your report, because it is very important for conservators and also for people who will be still dealing with these coins in the future. As for the recommendation and conclusion, when cleaning ancient coins, be caution and patience. Cleaning ancient coins mechanically is the most effective method. Chemical cleaning should be avoided as much as possible, and ammonia solution should be avoided. During the coin treatment processing, keep track of all the actions and details that we are taking and followed. When treating ancient coins with plasma, must begin with gently cleaning, assess your results, and then decide whether to continue or stop. Stop immediately when reaching the original surface of the archaeological coin. The use of a laser beam to clean coins is not recommended, since the laser impulse affects the coin surface by melting it locally. Coating is rarely required to be of properly cleaned and correctly preserved coins. When the preservation environment contains chemicals that damage the metal of coins, or when coins have been cleaned with a destructive approach, stabilizing may appear to be necessary. Avoiding strong coins, different metals side by side in the same drawer or showcase as much as possible. Set the ideal environment conditions when displaying or storing archaeological coins, like particularly for the RH lower than 35% and for temperature between 18 to 22. You have to do periodic maintenance of the traded coins to check that no changes have acquired. And if you are working on a project of conservation of ancient coins, here's the tools and devices that you need to do this with good way. And thank you so much for your attention. And please, if you have any questions, I would be happy to answer them as much as I can. Thank you.
Great. Thank you so much. That was fantastic. I think, I speak for all of us when you say that was a great presentation. We really enjoyed
Thank you.
learning so much about your work and your research, and thank you for so generously sharing it with us.
My
So now
pleasure.
Yeah, well, we can take a couple questions, I think. If you have questions, please submit them to the Q&A. And Marisa and myself will read them to Dr. Elshahawi, and he can answer them.
I would like to ask a question to sort of start it off. Do you find that if a object is being faked, that there is intentional corrosion made from some of the chemicals that are used to make it look like it's older than it is? Have you encountered that in any of the objects that you've worked on?
Yes, at some point, particularly when we are working on some coins, some people, but this actually away from the museum because, as you know, Egypt, it is dealing with a good way with the trading of ancient objects, and it is by law. So it is almost related to the private collection. Some people trying to make the look more authenticity for several reasons to sometimes
Mm.
to make their objects looks very well as the ancient objects it is also away from the authenticity to achieve a good prices when they are selling their objects. So I have seen some cases about the uh, making like artificial corrosion on metal objects.
I see. Yeah, I guess if you're trying to sell it as a really old piece, then you would want it to look as, quote, authentic as possible. So, yeah, thank you very much.
Great. Let's see. Chat. Just let's see here. Okay, so maybe I'm not sure if the Q&A box is not working or something, but I've opened the chat up to everyone in case you want to put a question there in case there's some technical issues. So that's also an option. You can put it in the chat. I had a question as well. So you've mentioned that separating coins and storing them separately is important for conservation. So is it possible for coins, if they're close to each other in the same drawer in storage, or if they're being displayed like right next to each other in a museum case, that they could affect, the preservation conditions of each other? Like if some kind of bronze disease or something is still present, they could spread between the coins.
Yeah, it might be having. So actually for two um process or two reaction. One, as you mentioned about the active corrosion, particularly when we have coins that severe from active corrosion, we should separate away from the other coins because it might be moved to other coins and we have to store these coins below 30% of RH until we take the action to deal with this phenomena because it is active and we should do treatment. So the whole conservators around the world, the one thing that all agreed about making a treatment for the ancient coins or ancient metal artifacts when they have active corrosion. We should do treatment. And this actually I don't have the time to go in more detail with how we deal with a treatment of active corrosion, but actually we use different materials like zinc oxide or silver oxide or aluminum oxide, any of these material. But actually for the silver oxide, it is very expensive and something related to also the safety, because it is like explosion materials. You cannot like request it by yourself. You can request it by the institution itself, not by yourself. But still, you can use any of these materials after removing the active spots mechanically, then put spots of zinc oxide or aluminum oxide for uh, like 2 minutes, and then you have to apply corrosion inhibitors at the end coating layer. And also, as I mentioned, put different materials together or stick related to the reaction that might happen between the different materials. Like, as I mentioned in my presentation, if you put like silver with copper, silver with iron, and I'm talking here away from coins, but related to regards the main topic of the lecture about the metals, this might cause a corrosion regards to the electrochemical corrosion that might happen between different materials, particularly when we have a high amount of relative humidity, like let's say more than 70%. So we
Ah,
should
that's really
separate.
interesting.
Yeah.
Yeah, that's so great. That's so
Yeah.
interesting. Um, we do have a question from the chats, a couple questions. First, how can you decide the crack in the cattail in the X-ray image is modern and not due to a casting defect?
So actually, the crack, it is not related to what we have decided if the cat it is ancient or modern. So one thing that led people, especially curators at the J. Paul Getty, let's talk about Judith Barr, the one who raised the question about the authenticity of the cat in the beginning. So one thing, it was related to the odd repairs, not for the cracks. So the cracks might be from the producing techniques, might be from, of course, the cats belongs now to like 3,000 years ago. That might happen. Even you are making a good statue, because these cracks we can't see it with our naked eye. We only have seen these cracks using the radiograph, because it was micro cracks, not crack as we can see it by our naked eye. So the one thing more than the cracks, it was regards to the odd repairs.
Got it. Yeah. Thank you so much. And then it seems like we have one more question. So when do you decide that the chemical or electrochemical treatment is finished and you have reached the complete removal of the corrosion?
So there's a good question, and I might went through it through the lecture. So let's talk about the electrochemical treatment. Actually, for now, it is not are using more, especially when you are working in museums, because when you are working in the museum or inside the museum, it is totally different, as I have mentioned, comparing when you are working on the site. So as for the chemical treatment, you are trying to do or to achieve two things. One thing is try to remove the corrosion layer for long-term preservation, and the second to let the inscriptions and writings access to numismatists. So when I have to decide, I have to decide this when I will be able to reach the original surface. when I will be able to read the inscriptions from the surface of the coins, as well as when I'm trying to make the rinsing process, and when I reach the uh, pH of the coins to nature, which is 7, I have to stop. So I achieved all of these. That's mean the corrosion layer has been removed. I became able to write the inscriptions as well as reach the original surface, which is the main goal of the conservation of ancient coins.
Great. Thank you
I
so
think you
much.
bring up a really good point about how over cleaning could possibly be just as dangerous as leaving the corrosion on the piece. That if you over clean it, you might distort the image or not be able to read it anymore.
Yes, yes, it is. It is. Before we go in deep with uh cleaning process on some coins, we have to assess the method that we are planning to use. As I have said, you have to try it with a small area on the edge to make an assessment of your method and how the results. Then after you make the assessment, you can continue with cleaning process, or you can stop or assess another method to continue. Yeah, but just be careful. At some point, treatment might cause more problem to the coins. So at some point, we prefer to leave it. Uh, compare, yeah, to try to keep it in a good situation until we find the good solution or the good method of conservation.
Yeah. Yeah, thank you so much. I mean, it looks like we've answered the questions from the audience. So thank you again for coming to speak for us. And thank you again, everybody who came out to our lecture today. Thank you all, and have a great day.
Yes, thank you.
Thank you.
Thank you so
Bye.
much.